Good morning, colleagues. Today we are going to do marking discussion for Technical Mathematics, Paper 2. Without wasting time, I'm sure you have the program that indicated that today is marking discussion for Paper 2, Technical Mathematics. And then when you look at the marking guideline, outside it indicates the codes. The codes will assist you in marking your learners and understanding the marking guideline. As you can see, you have A there, which says accuracy. What do you mean by accuracy? It means your experience applies, because this is where we have a gray area in the schools that I visited when we were doing moderation of Common Test Term 1. Many colleagues struggled to apply CA marking throughout their marking of their Term 1 common test. So we'll have to explain this as we continue marking as to how does it apply. And then I is for identity. Identity, for instance, tangent is sine over cos. Where you see identity, for that identity of tangent, sine over cos, allocated a mark, then it will be indicated by I, which means it is an identity. And then F is for correct formula. And then M, which is the method mark. Method mark is what the learner did in getting the answer, which is the method mark. And then it will be indicated that you should not penalize a learner for incorrect units or units not being written. You only look at the value that is being calculated by the learner. And the other one is R, which is rounding. Where you see R, it means the learner is penalized for that question if rounding is not correct. And then RE is for reason, particularly in Euclid geometry, where learners are finding the angles and give reasons for the magnitude of angles found. And then you have S, which is simplification, and then SF, which is substitution in correct formula. And then we have ST, which is the statement. ST and R, it means in that particular question, you don't mark the statement, you don't mark and the reason. You mark for both statement and reason, then it will be a mark. So please familiarize yourself with the codes indicated here so that you are able to make your marking easier. Now, colleagues, as you move on, you get to question number 1. As you look at question number 1, the first question here, you are calculating an angle alpha here. Now, the mark is only 1. We have mark allocated here 1, and this is A. Like I indicated, A is an accuracy mark. You don't expect any answer except 104 degrees. Therefore, this is the only answer expected in this question, and like I indicated, it's an accuracy mark. And when you move to 1.2, the first mark, it is 2 marks where you are calculating the distance. The first mark here is for substitution in the distance formula. And substitution in the distance formula, it's an accuracy mark. But saying it's an accuracy mark, check, colleagues, you have -2 minus into -8 all squared plus 8 minus into -4 all squared. You might find instances where learners wrote it as they start with -8, then they come to -2, which is squared, and then plus, you can have -4 minus 8 all squared. Please check on the sequence of the learner substitution here. We started with -2 as per the marking guideline and came to -8, came to 8, and then -4. But if a learner writes -8 minus into -2 all squared, because this answer will still give us the same answer here, because remember this is 36, and when you get this one you get -6, and -6 squared is still 36. The same applies here. You have -4 minus 8, which is -12, and -12 squared is 144. Please check the order of substitution here. It is still the same. So 1 mark for substitution, which is an accuracy mark, and then the CA mark for the length. What do we mean by the CA mark? Let's say, for instance, learners substituted here. When they substituted, Instead of saying negative 2 minus minus 8, they write negative 2 minus 8, which will give us negative 10. Negative 10 squared is 100. Therefore, the learner is penalized for substitution. But if pressing a calculator based on an incorrect substitution, the value of the length is correct. That is what you call a CA. You give a learner a mark because you can't penalize a learner twice. You penalized a learner here, but he made a mistake, but the mistake done in the first step is correctly executed in the last step. That is a CA mark. Then a learner will get 1 out of 2. Penalized 1 mark for substitution. And then when you get to 1.3, it says now find the gradient. The first mark, remember the gradient is equals to tangent theta. The first mark is SF. What does SF mean? It means substitution in the correct formula. And therefore, the angle that was given as indicated in the diagram here is 76 degrees. The learner substitute now by theta to be 76 degrees. Therefore, it's a mark for what? For the correct substitution. And then the mark for the gradient. But please take note, colleagues. Gradient is a CA mark. That simply implies if a learner did not substitute by 76 degrees, substituted by any angle that we do not know, then it becomes a CA mark because pressing a calculator to get him 4, then it's still correct. Therefore, it becomes a CA mark. The learner will be penalized for substitution, but it will be a CA mark for the angle calculated. And now let's look at 1.4. 1.4, you are finding the equation. The first mark will be for the gradient. 1 mark for the gradient. And what is this mark for? It is a accuracy mark. And then after calculating, gradient has been calculated here. Now we have the learner's response as gradient is equal to 4, then it becomes a mark. Now what will be the next mark allocation? It will be for substitution in the formula. Look, the first mark is accuracy mark, but the remaining ones are continuous accuracy. Therefore, if the learner's gradient is incorrect, but it is correctly substituted in the formula here, where the point -2 and 8 are used, therefore, learner will get a mark for the correct substitution, and the following mark will be for simplification, and the last mark will be for the equation. Remember, colleagues, some learners will use y is equals to mx plus c, where you have y to be -2, you have the gradient to be 4, and the value of x is 8 plus c, which will therefore mean you have -2 equals to 32 plus c. And from here you can see that c is equals to -34. And therefore the equation will be y is equals to 4x minus 34. In this case, learner will get a mark like we indicated here. The gradient is 4, it's a mark. The second mark will be for substitution in the correct formula. And then the third mark, this is an option, colleagues, and the third mark will be for the value of c, and the last mark will be for the equation. And therefore the mark allocation for this question, which is 1.4, becomes what? 4 marks. Now, colleagues, as you continue, moving to 1.5. 1.5 here you have to find, learners were required to find the midpoint of AF. Now the first mark is substitution in the correct formula. And then substitution in the correct formula, it becomes an accuracy mark, and then the gradient, the midpoint. And the midpoint, in this case, it's not a CA mark, it is also an accuracy mark. That simply implies, colleagues, AO, full marks. If a learner now do not indicate substituting the correct formula, but you see the answer to be -5 and 2, therefore that learner will get 1 mark for -5 and 1 mark for 2. That is in a case the learner did not substitute in the formula. Now the question can be again, what if you have a situation where a learner used incorrect formula. Colleagues, incorrect formula, it becomes a breakdown. I repeat, colleagues, if incorrect formula was used, it becomes a breakdown. Therefore, if the formula is not correct here, the learner will get what? 0 marks. The same applies with the previous questions. Let's look. 1.2, it required the formula. And in the formula, if the formula is incorrect, that will be 0 out of 2. You go to this 1.3, the formula is applied for an angle of inclination. Therefore, if it is incorrect, it becomes breakdown again. The same applies with this one. The formula must be correct. Remember, the statement says substitution not in the formula, substitution in the correct formula. Then it will guarantee the CA marks in the follow-up questions, follow-up steps. I'm sorry. Now looking at 1.6. 1.6 for 5 marks. The first mark, colleagues, will be substitution in the formula, which is an accuracy mark. Substitution in the formula can be this one or this one or this one, but substitution in the formula is an accuracy mark. That is the first mark. And the second mark will be the gradient. But the gradient now becomes what? The CA mark, based on if a learner indicates substituted incorrectly. But incorrect substitution used correctly to find the gradient, it becomes the CA mark. And then from there, you find the gradient of the perpendicular bisector, which is this one, which is -1/2. But please, colleagues, let us note, this is a CA mark, provided it is calculated based on the calculated gradient in the second step. I repeat, this must be, the gradient of the perpendicular line must be in relation to the gradient here, where the condition is applied. So if a learner gets 5 here, logic says the gradient of the perpendicular bisector must be -1/2, -1/5. If it is -half here, then the gradient of this one must be 2. It's a CA mark, but depending on the value of the gradient here. It can't come from nowhere. It must come from the step. It's a CA mark. The mark for the perpendicular gradient, it depends on what the learner got in the second step. Therefore, it's a CA mark in relation to this gradient. And then the next mark will be, remember we said accuracy mark, continuous accuracy, but continuous accuracy depending on the gradient here. And then from there, the second mark will be substitution in the correct formula. But colleagues, substitution in the correct formula, it's a CA mark, because if a learner makes a mistake here, and that mistake is correctly utilized in terms of substitution here, it becomes the CA mark here. And then the equation will also be a CA mark. Therefore, in 1.6, accuracy mark is only where you are substituting for the gradient of AF. And then from there it becomes the CA mark. Now, colleagues, as you continue now, moving on to question number 2. When you look at question number 2, colleagues, 2.1.1, mark allocation there is 2 marks. And then you can see written bold, capital, AO, full marks. Answer only full marks. Therefore, if you see the equation x squared plus y squared is equal to 25, learner must get what? Full marks. But colleagues, please take note. You'll find instances where learners write the square root of 25 minus x squared. You give marks here if the learner wrote x plus or minus. If you see the solution as x squared plus y squared is equal to 25, like we indicated here, answer only full marks. Let's say, for instance, you have a learner who will write y is equal to plus or minus the square root of 25 minus x squared. It's still the same as this one. So you give this learner full marks for writing it this way. Only if you have plus or minus, then it will be 2 marks. And now as we move on, 2.1.2a, the coordinates of B, only 1 mark, colleagues. And this 1 mark is for coordinates. You can't expect any answer except 4 and 3. and this is an accuracy mark. This is the only answer expected from our learners. And now 2.1.2b, you find the gradient of PQ. Gradient of PQ now in this case is negative 4/3. Look, colleagues, it's A. It's an accuracy mark. You don't expect any answer except negative 4/3. It's an accuracy mark. So in this question, 2.1.1, 2.1.2a, and 2.1.2b, all of them are accuracy marks. Therefore, these are the only answers expected. And now 2.1.3, colleagues, the first mark is substitution in the correct formula. Now check, it's CA. From the way it goes, it's CA. Now the question will be, why is it CA the first step? It's a CA mark from question 2.1.2a and question 2.1.2b. Why? Because the answer here depends on the coordinate of B. The gradient depends on the answer the learner got in 2.1.2b. Therefore, if the learner here, the coordinates are wrong, the gradient is wrong, but these wrong coordinates and wrong gradients are correctly used in 2.1.3, it becomes a consistent accuracy mark. Therefore, this learner will get a mark here based on the answers obtained in 2.1.2a, like I indicated, and 2.1.2b. Therefore, it will be a continuous accuracy mark. And then, again, you have another mark. Mark for what? For simplification. And the marking guideline is very clear. It says substitution in the correct formula, it's a CA mark. From where? From question 2.1.2a and question 2.1.2b. Please follow this marking guideline very well. You will surely mark these learners correctly if you follow it. And then the last mark will be the equation, which is also the continuous accuracy mark. Now, you have an option there. Remember, we used this formula like we indicated in question, I think it was in question 1.4. In 1.4, where I indicated this as an option. The same applies in 2.1.3, where you have an option where y is equals to mx plus c is used. Therefore, same way, you give learner what? 1 mark for substitution. Substitution step is this one, colleagues, 1 mark for substitution, and this is your continuous accuracy mark. And then the second mark will be for the value of C, and it's an consistent accuracy mark, and then the equation. The same applies with what we did with 1.4, like I indicated. Now 2.2.1, colleagues, where you write the equation of an ellipse in the form a squared over x squared over a squared plus y squared over b squared equals to 1. Now, what is the first mark? The first mark is for dividing both sides by 32. By dividing both sides by 32, and then it's a mark, and then this is an accuracy mark. This is an accuracy mark, and then the last mark will be the correct set form. Therefore, you have x squared divided by 4 square root of 2 squared plus y squared divided by 2 squared equals to 1. Or you can also accept x squared all over square root of 32 squared plus y squared all over 2 squared equals to 1. And then this one is a continuous accuracy mark based on what the learner wrote in the first step. And 2.2.2, right, 2.2.2, check, it says CA from question 2.2.1. Why is it C8? You'll find instances where learners from nowhere, I don't know, from nowhere, you find a learner writing this as is equals to 1. I'm just making an example that the substitutions here are not correct. Obviously, if this is I'm just making an example. If a learner indicates this as a solution, it implies that you will have the x cards at -3 and 3. You'll have the y cards at 2 and 2. So the drawing of an ellipse depends on the learner solution in 2.2.1. Please take note of that. What the learner wrote as an equation of an ellipse, follow it up in 2.2.2 to see if the graph is correct according to the equation written by the learner in 2.2.1. Now, 1 mark for both y-intercept, 1 mark for 2 and negative 2. It means both of them must be correct based on what is written here. And then the second mark will be for both x-intercepts, the x cards. And then the last mark will be for elliptical shapes. Colleagues, let's say, for instance, you have this learner who is drawing an ellipse, This is an ellipse. Mine might not be necessarily nice, but check, an ellipse. Obviously, the intercepts are wrong. But the shape of an ellipse, irrespective where it cuts, as long as you see a shape of an ellipse, then that is correct. Look at the shape, colleagues. Shape, as long as the shape is as long as it's an elliptical shape, you give a mark for an elliptical shape. Irrespective as to where it cuts, then you give a mark for elliptical shapes. Therefore, in 2.2.2, 3 marks, like I indicated, all marks are consistent accuracy marks based on the answer obtained in 2.2.1. Now, as you move on, colleagues, to question 3. Now, when you look at question 3, sine 2 alpha, learners were given an angle 32 degrees. Therefore, sine 3 into 32 degrees, and then the magnitude of sine 3 alpha, which is equal to 0.99. And colleagues, it's 1 mark, and this 1 mark is an accuracy 1. So you don't expect any answer except 0.99. But check, NPR, no penalty for rounding. If a learner writes 0.98, it's about rounding. That learner must be given a mark. Some learners will write it as 1.00. No penalty for rounding. Then it's 1 mark. 3.1.2, you have sec squared theta minus 1 over tan alpha. Angles are given again. You have sec squared 20 degrees minus 1 divided by tan 32 degrees. No mark for substitution. No mark for substitution, colleagues. Let us not just mark. No mark for substitution. And then the second mark is for, the first mark is for I. What is this I? To write sec squared 20 as 1 over cos 20. An identity, colleagues. 1 mark. And it must be an accuracy mark. And then the second mark will be for 0.21. And it is a CA mark. Some learners, for some reasons that we don't know, they might write sec as 1 over sine. 1 over sine 20 degrees. So it means the identity is wrong. But pressing your calculator, the answer is right according to the mistake committed here. Therefore, it becomes a CA mark. And obviously, the answer will not be the same as this one. Please, colleagues, if the identity is wrong, take out the calculator as a teacher, press and check according to the calculations, is that answer correct based on the mistake committed by the learner in the first step? Then it's a CA mark. So you must have your calculator with you. Do the calculations. You penalize the learner here. You can't penalize him again here. Therefore, you must press and check, confirm if what the learner wrote here is in relation to what he wrote. And you penalize once, but this must be a CA mark. And out of 2 marks, therefore this learner will get 1 out of 2 if the identity is incorrect. And then the alternative, sec squared theta minus 1. Now you have a learner that will change this identity to be tan squared theta. Identity. The mark will be writing sec squared theta minus 1 as tan squared. Sec squared theta minus 1 as tan squared 20 degrees. Why? Because remember you said theta is equals to 20 degrees. Therefore it becomes tan squared 20 degrees divided by tan 32 degrees. And therefore 1 mark for identity. And the next mark will be for the value. And no penalty for rounding like we indicated. If a learner writes 0.2, no penalty for rounding. You accept 0.2 as an answer because the marking guideline says no penalty for rounding. And answer only full marks. If you don't see the identity written, you don't see the identity written, the learner writes the question and say equals to 0.21. You give 2 marks, full marks, if the identity is not shown as per the marking guideline. Follow it religiously so. And now you move on to 3.2.1. 3.2.1, you have to express the ratios in terms of M. Now the first mark will be for calculating R using the theorem of Pythagoras. And therefore this becomes your accuracy mark. This is your accuracy mark. You can't expect any answer except M squared plus 1. Colleagues, let us not be petty. You will find learners writing plus or minus I. Just close your eyes and give 1 mark. Plus or minus square root of M squared plus 1. Give them a mark. We know that R cannot be negative, it is positive, the hypotenuse side, but please allocate a mark. As long as you see the square root of M squared plus 1, you give a mark, though it is an accuracy mark. Please, what is important here is the square root of M squared plus 1. Plus or minus, it's fine. Underline, but give a mark for that. And then the second one, the second mark will be for writing the ratio for sine 35 degrees in terms of M. Remember, sine is opposite over hypotenuse. The definition says sine is y over r, and y is 1. R is the square root of M squared plus 1. And this is a mark, CA mark. Why CA mark? If R is not correct here, but when writing the ratio, it is correct based on an incorrect answer in the first step, this learner will get 1 out of mark because it says CA mark. Right. And then we continue, colleagues, moving to 3.2.2. Looking at 3.2.2, colleagues, you have now cos 29 over 36 pi times tan 7 over 36 pi. What do we have here? The first mark is changing to degrees, changing radians, radiant angles to degrees. Therefore, 1 mark for changing both. That is 135 degrees and 35 degrees. It will be a mark, and it is an accuracy mark. Right? As you continue, the second mark will be negative cos 35. Negative cos 35 from the reductions. Remember 135, 145 is in the second quadrant. And in the second quadrant, we have 180 minus 35 in terms of 44, 145 here. And then you give a mark for this one. And it is also an accuracy mark. It's an accuracy mark. And then the second mark will be writing the identity. Tangent, the quotient identity is sine 35 degrees divided by cos 35 degrees, and the learner will get what? A mark for identity. Let us not forget, first mark for writing 145 is an acute angle, from obtuse to acute angle, and please take note, it must be negative because this number is in the second quadrant. The second mark will be for the quotient identity tangent 35, writing it as sine 35 degrees divided by cos 35 degrees, which is an identity. 3 marks already. And then the last mark will be, not the last mark, you'll have another mark, which is simplification. Where do you get simplification? Cos 35 into cos 35, it goes once. You are left with negative sine 35 degrees. That is your simplification mark. And the last mark will be writing the ratio of sine 35 degrees in terms of m, which will be negative 1 over square root of m squared plus 1. This is your last mark. So, colleagues, please take note. The first 4 marks are accuracy marks. You don't expect anything except what you see here in the first 3 marks. This is accuracy mark. Even the simplification is an accuracy mark. Remember, changing from radians to degrees is an accuracy mark. The only consistent accuracy mark will be in the final step, depending on what the learner gets here. If a learner gets cosec, for instance, cosec, and the ratio is correct based on the cosec written here, therefore that will be the only consistent accuracy mark here. Please, colleagues, take note of that. You have the alternative here, and in the alternative, the first mark, like it is the case with the first option, is changing radian angles to degrees. And the second mark will be the acute angle, which is negative. And then in this case, tangent is not changed. What you have now, you have the ratio of cos. 1 mark for the ratio of cos, it's correct. And 1 mark for the ratio of tangent, correct. And the last mark will be for the ratio of the whole expression here, which will be 5 marks. And colleagues, please take note. Accuracy mark, let's correct it here. The ratio for cos, it can't be a CA mark. It's an accuracy mark, like it is the case. The marking guideline must talk the same language from the first option up to the last option. Therefore, it's accuracy. And the last mark, which is the fifth, becomes the continuous accuracy based on what is written in the ratios here. Right. And the last option, you have the first mark for reduction. What do you mean reduction? Finding the reductions in terms of pi here for this angle will be a mark. And then expressing this reduction as -7/36 pi is a mark. And 1 mark for identity. Check here, the angle is not changed from radians to degrees. It remains. And then from there, 1 mark for simplification. That is, you have simplified, and there are mark for the ratio. And that will be 5 marks. And again here, colleagues, please take note. It is an accuracy. And the ratio of sign 1, 2, 1, 2, 3, 4. 1, 2, 3, 4. 1 mark is missing. Let's check the reduction. And then 1, 2, we said reduction. Simplifying the reduction, identity, simplification, and the trig ratio. So therefore, we have simplification, we have reduction, and writing, don't forget the mark for negative cos, 7/36 pi. Oh, it is there. The mark is there. Let's check again. We said reduction, -6, or another mark for identity. All these marks are accuracy mark, and then the simplification, 1, 2, 3, 4, and the last mark will be for the ratio of the whole expression, and that will give you 5 marks. And then colleagues, 3.3.1, you have 2 cos theta plus sin theta equals to 0. The first mark will be for sin theta is equals to -2 cos theta. That is transposing this on the side. It's a mark, it's an accuracy mark. And then the second mark will be for dividing both sides by cos. Dividing both sides by cos, it's a mark. And then, colleagues, this is only 2 marks. Remember, the question said, write it in the form of a tangent. It's a proof question. So you give 1 mark for transposing and 1 mark for dividing both sides by cos. And that will be 2 marks. And both of them are accuracy marks. You can't have an instance where learners now divide by sign. Once they divide by sign, it means they'll have chord and not tangent. So it becomes 2 marks. The alternative, first mark for transposing. This time we transpose 2 cos theta. And in this case, we are now transposing positive sin theta, which will be negative, sin theta 1 mark. And then the second mark will be now dividing both sides by sine. As you divide by a sign, it will lead you to cot, and cot will lead to 1 over tangent, which will lead to this one. So we still get 2 marks here. And then these are accuracy marks. Now, colleagues, this doesn't make sense. 1 mark for transposing. The second mark, colleagues, please. The second mark will be for 1 over tangent theta, because this 1 over tangent theta is the one that will change cot to be tangent after you cross multiply. Please take note of that. You don't give a mark for dividing both sides by side, but you do give a mark for 1 over tan theta. And this is also an accuracy mark, and it will be 2 marks. Now, as you continue, 3.3.2, tangent theta is equals to -2. 1 mark will be for the reference angle. First mark will be for the reference angle. And then the second mark will be for both second quadrant as well as the fourth quadrant. Both of them a mark. And these 2 are consistent accuracy marks. And then you get a mark for the angle, and then the mark for another angle. And these 2 are CA marks. They depend on what the learner wrote as the reference angle. If the reference angle is wrong, but correctly used in the quadrants and correctly used in finding the angles, it becomes a CA mark. Colleagues, please take note. This A is not referring to angle incorrect. Angle is incorrect. It's okay. But that angle that is incorrect is used in the correct quadrant. That is 180 minus. Is used in the correct quadrant, 360 minus. That simply means for this mark, you concentrate on 180 minus, irrespective whether the angle is wrong. You concentrate on 180 minus. That is what is meant by the correct quadrant. You concentrate on 360 minus. That is where you allocate a mark. It becomes an accuracy mark. But remember, this accuracy mark can be in line with an incorrect reference angle. So if the reference angle is incorrect here, the learner is penalized. But that reference angle is used correctly in the correct quadrant. It's used correctly in the correct quadrant. Therefore, that learner will get a mark for both quadrants being correct. It's 1 mark. And then you'll get 1 mark here, 1 mark here. And therefore, if the reference angle is incorrect, the answers will not be the same. You need to follow what the learner wrote here as long as the quadrants are correct. But if the quadrants are not correct, you can't give a mark, because otherwise the answer will fall outside the range given. Then question 3 will be out of 16 marks. Can we kindly take a 5 minutes break and come back, colleagues? 5 minutes. I need to take water, please.
Good afternoon, colleagues. I'm continuing over what Mr. Lidiban has just left. We are still discussing the marking guidelines, the memorandum. So we have to start at question 4. If we look at question 4, the learners were requested to complete the identity. As you can see here, it's 1 mark, and it's also accuracy, because this is an identity, where learners should be knowing they are identities. Now, if you look at 4.1.2, you realize that there's a mark when a learner changes tan squared A into sine over cos A. It's a mark, and it's also accurate, because I believe this is an identity, quotient identity, where learners should know that when you convert, you change tangent into sine over cos. And then the reciprocal, which is cosec here, its reciprocal will be 1 over sine squared A. And then we know that cos of 360, remember this is 2 pi, will give us 1. And then that will be -1. And then here when we simplify, I'm sure you can realize that now sine and sine will divide each other, and then we'll be left with 1 over cos squared A minus 1. And then if you remember now from the identities that 1 minus cos squared A is the same as sine squared A. This is the square identity. And then as you can see here, there is a CA, because maybe learners may not be able now to find, to change 1 minus cos squared A to become sine squared A. So here, for continuous accuracy, this is where we follow a learner. With that is wrong, but we now have to CA. It means that is wrong here. But now, after simplification, maybe learner can say this is cos squared A, and then the answer would be 1. But now, because of the CA, we'll have to punish a learner for what is wrong and then continue marking what is correct. And then another alternative provided here, it is given that if a learner can change this cosec squared into 1 plus cot squared A, I'm sure, colleagues, we can see this is accuracy, both marks, for changing of 1 plus cot squared A. Remember, this is identity, so learners should be accurate here. But now, when they come to the simplification, especially the product, this is where we're going to apply our CA. Because maybe most learners may not be able now to calculate or remove the bracket here correctly. So, and then if we look at 4.1.3, this is where we award a mark for changing sine into sine theta over cos theta. Also to change cot theta into cos theta over sine theta. Now these two are also accuracy marks, accurate marks. But look at the simplification. Simplification now has to be CA, because if learners are not good with the fractions, to look for LCD here, whereby they can simplify that. That's when we're going to apply CA. And then another mark will be 1, because this is a square identity. Sine squared theta plus cos squared theta will always give us 1. And then when they simplify, they get the answer to be 1 over sine theta. Of course, other learners may provide cosec theta. This is also acceptable as the final simplification. Then if we look at the next page, we see that there is another alternative provided. Another alternative here provided is that learners may be multiplying the brackets here, removing the brackets. Now after multiplying, this is where they also have to get a mark for changing tan theta into sine theta over cos theta. And then coming to cot theta, which is the same as cos theta over sine theta. They also get a mark which is accuracy. And then here, they also have to learn how to simplify. I'm sure we realize here, cos theta multiplied by cos theta will give us cos squared theta. And then here, when they simplify, they multiply this one by that one. Sine theta multiplied by sine theta, it will give us sine squared theta. Now, sine squared theta plus cos theta, we know it's 1. It's also giving us the same answer. Another alternative, the last alternative now. Remember, learners now know cot as 1 over tan theta. And then a learner may write this, 1 over tan theta. We also give a mark here. And then we come and say, after they simplify here, they get tan squared theta plus cos plus 1, which is the same as sec squared theta. So after simplification, they realize that, okay, cos and cos will cancel, and then that other one will cancel this other one. And then we're going to be left with 1 over sine. The same answer they still get. And then coming to 4.2.1, sec of 60. Remember, sec of 60 comes from 1 over cos 60. And now, cos 60 is 1 over 2. So this one becomes 2. And then the 1 mark that is provided here, it has to be the accuracy mark, because learners have to know their reciprocals. I think here is a mistake here. For that 2, it shouldn't be there. Or a mark for the 2. Yes, a mark for 2 is there. And then coming to 4.2.2, we realize here, learners have to prove that left-hand side is equals to right-hand side. It means learners are picking the left-hand side and simplify. And then cosec into 180 plus. 180 plus is our third quadrant. And we know that cosec is a reciprocal of sine. So therefore it will be negative. And then 360 minus is also in the fourth quadrant. And we realize that sine is also negative in the fourth quadrant. And then if they simplify here, we know that it's going to be negative sine theta. But if we square it, it becomes positive. But there is this negative sign that has already been there. That has always been there. I'm sure we can realize here, colleagues. And then sine is negative, and negative sine squared will come out positive. And then if you multiply the two, you will realize that you are left with 1, but negative 1 multiplied by negative 1 will give us positive 1. And then we'll be left with 1 minus sine squared theta, which is the same as cos squared theta. Therefore, accuracy mark for cosec, negative cosec theta, and accurate mark for negative sine theta because of the quadrant. In other words, here learners must be able to apply their reduction formula. They need to know their CAS diagram where we have 4 quadrants. Learners should be able to identify which quadrant will sine be negative or positive. Hence, we can see here, the last mark is the one that is CA now. But if you look at all other marks, 1, 2, 3, 4, it's accuracy. Okay, colleagues, we move to 4 point. Let's look at the next page. We look at question 5. This is a total mark of question 4 here. As we can see, we move now to question 5. These are our trig graphs that learners have to be able to interpret here. If we look at question 5, 5.1, 1 mark for period, which is accuracy. Because I think learners will always try to confuse it, because this is not a complete circle for the graph. So for it to be complete, it has to have 360. So it's accuracy mark. And then the value of A now is negative 2. It is also accuracy. As we can see now, the graph will start here in the horizontal x-axis, below horizontal x-axis, where y is negative. And then the value of B will now become 2. These are also accuracy marks as well. And then calculating the coordinates of T, as we can see here, they also share the same y value, but the x value, this is where they substitute into the equation to get 158,5 is to negative 0,7. Both marks for x coordinate and y coordinate are also accuracy marks. If we come here, we also said, the question said, for what values of x will the graph be above horizontal x-axis? As we can see here, or below, yes, the product of the two. This is the interval where the graph will be able to satisfy the statement between x and between 135 and 180 degrees. These are our endpoints. Accuracy mark we give. If the learners have a notation, like for instance, x is an element of 135 degrees and 180 degrees, we also award a mark. In case a learner writes both intervals, ignore this one. 0 is less than x and x is less than 45. I'm sure we can see on our guideline, colleagues. And then the last one is when x is equals to 45 and when x is equals to 135. That's where the f at x and g at x will be undefined. Colleagues, this is the end of question 5, 9 marks. We move to question 6. If we look at question 6, we are given a diagram and learners were requested to calculate the length of AC. What is given here is the side as well as the angle. And when you look at our triangle, it's a right-angled triangle, whereby they can use one of the trig ratios. either sine, cos, or tangent. But in this case, because adjacent side is provided, and we are looking for the hypotenuse side, therefore they can use cos of 50 degrees, which is adjacent over hypotenuse. Then for the trig ratio, it's a 1 mark. Making AC the subject of the formula, it's also a mark, and then the length is also a mark. Or another alternative provided here is that learners may be saying AB is equals to 150 tan 50, and then it's also a mark, and then when they simplify here, they also get the same answer to be 233,36 meters. Another alternative is BAC is equals to 40 degrees, then one can say sine 40, as you can see, this one will be 40 degrees. Then another alternative may be sine 40, which is opposite over hypotenuse, because now this side will become the opposite. If a learner decided to look for the angle A, because you can say 90 minus 50, it will give us 40. So a learner may approach it with this alternative to say sine 40 degrees is equals to 150 now, which becomes the opposite side, and then all over the hypotenuse side, which is AC, and then the answer will still be the same. We also have another alternative on the next page, colleagues. We realize that a learner may also say, let me apply the sine rule. It will still give the same answer, 150 over sine 40 and AC over sine 90. And then the answer will still be the same. Here we are provided with the area, and we need to find or calculate angle beta. And then here learners have to substitute what is given. The area is given. The side AC, we just calculated it there. And then the given side, which is 300. And therefore, to make beta the subject of the formula, learners have to look for the reference angle. In this case, in which quadrant will now sine be positive? And then that is why you see 180 minus the reference angle, which is 74 degrees. I'm sure even when we look at the diagram, we realize that that angle must be greater than 90 degrees. Another alternative provided, colleagues, is that the area is given here. And then learners may decide immediately to make sine beta the subject of the formula here. And the answer will still be the same. So as we can see, please, as we mark, we follow the guideline. If it's A, it means it's accuracy mark for the formula. And then CA for the substitution into the correct formula. And then we can apply CA there. And then the answer would still be 106 degrees. And then moving to 6.3, colleagues, we realize here we were requested to calculate the side AD. Here learners applied the cosine rule, where they make that side the subject of the formula. And then if you square it, it will give you 427,84 meters. So formula accuracy. Why accuracy? Because it is there in their formula sheet, even in the question paper, it's there. So learners have to just take it and put it here and substitute, so that now they can be able to find, to substitute the values that are given. And then when they square, the square root of 183,050,5296 will give us 427,84. Colleagues, we move on to question 7. This is Euclidean geometry, where learners have to complete the statement. Now, 1 mark for statement and accuracy, because this is from the theorem statement. When you look at 7.2.1, learners are requested to find angle C1, this angle here. Then they say angle C1 is equals to 26,6, and then the reason is angle in the same segment. I'm sure we can see the bow tie here. So this angle will be equals to C1. And then statement and the reason are accuracy marks. Another alternative is that a learner may be able to realize that the given side is 4 here and the other side is there, and then they can also use the ratio, which is sine C1. It will be opposite side over the hypotenuse side. And then learners will now be able to find angle C1, which becomes the same answer as 26,6 degrees. So 1 mark for the ratio on the second alternative and the size of C1, which is also accuracy mark. Now colleagues, if we look at number B, 7.2.1b, here we are looking for angle A, this angle. So if learners have already found C1 to be 26,6 degrees, it means now it would be easy for them now to say, let's look for angle A. And then our A becomes 63,4 degrees. Then if we move to another alternative here that is given to us, learners may be approaching it with exterior angles of a triangle. And then as you can see here, this can be CA mark from 7.2.1. CA mark from 7.2.1. In other words, it is based on what learners got it to be angle A. Right? Another alternative, learners can also use the ratio, because there are 2 sides that are given. So learners may also use cos A. If we look at 7.2.1 C, here we are also looking for B1. B1 is also 63,4 degrees. And then if we look at 7.2.2 ED here, 7.2.2a, sorry colleagues, AE will be 4 units. And then if we look at B, 7.2.2b, ED becomes, because they say in terms of x, so the answer will now be 5 minus x. So now it is also accuracy mark. As you can see, is 1 mark there. And then moving to 7.2.3, we realize that we are looking for the specific value of x. As you can see, we substituted there because remember it is given that x plus 5 for the radius, and then when we substitute there, you get your x to be 3. I'll be taking a break for now, and then we're going to continue with question 7.2.3 colleagues. I just want to take a break, and then when we come back, we can continue to question 8. Welcome colleagues. We took a break. We're done with question 7. We now come into question 8. And then this 8.1, as you can see, learners were requested to complete the theorem statement. And then it's 1 mark because it's also accuracy mark. And then here learners are requested, when you look at 8.2.1a, PTS is equals to R1, which is 56 degrees. And then angle, the statement, the reason will be angles in the same segment. So statement and a reason, accuracy mark. And then OSR is also equals to R1, which is 56 degrees. Now, we're going to say angles opposite equal sides, because it is given that 2 sides are equal. And then we realize that this is going to give us also a mark and a mark, which gives us 5 marks. And then coming to 8.2.2b, PSR is equals to 90 degrees. We say angle in the semi-second. And then we realize that the mark for statement and a mark for the reason. And then we are requested to calculate angle P1. We say P1 plus 90 degrees plus 56. Here, as you can see, 90 plus 56 because we are looking for P1. Therefore, P1 is 34 degrees. Total is 3. There is another alternative. If a learner will say O1 is equals to 112, the reason being angle at the center is equals to twice angle at the circumference. And then here they can also say P1 is equals to angle S1, which is equals to 34 degrees. So here the reason is angles opposite equal sides. Colleagues, we move to question 8.2.3c. We are looking for value for angle P2. We realize that it is 22 degrees. And then this is also CA. And then angle in the same segment is accuracy mark. Is the reason for angle P2 to be 22 degrees. So here we are looking for S1 plus S2 plus S3. They are 90 because if you remember the diagram, these are the angle in the semi-second. So it is subtended by diameter POR. The next page is page 19. We still continue to look for angle S3, which is becoming 22 degrees as well. Sum of angles in the triangle. And then it is also CA mark, and then statement and the reason, angles opposite equal sides, it is also accuracy mark. Colleagues, we move to question 9. If we look at question 9, the given diagram, we are requested to calculate angle P2. As you can see that, you can say angle P2 plus 98 is equals to 180 degrees. Now the reason here is opposite angles of a cyclic quad are supplementary. They add up to 180 degrees. Statement and a reason, a mark and a mark, 2 marks. And then 9.2, we are looking for angle P1. P1 becomes P1 plus 82 equals 180 degrees. We say angles on the straight line. Therefore, P1 becomes 98 degrees. Or learners may also use this alternative to say exterior angle of a cyclic quad. Moving forward, colleagues, 9.3. For 9.3, we realize that we are looking for angle L1, which can be tan chord. Statement and reason, tan chord. If we look at question 10, it is a right angle. They also complete the theorem statement as well. And then coming to this one, 8.2.1. I think numbering here is not correct, colleagues. It has to be 10.21 because here is 10.1. So I think it's a mistake here. It has to be 10.2.1. CBO will be 60 degrees. The reason being tangent perpendicular to the radius. And then if you look at 10.2.1b, angle D2 will be 30, tan chord. And then we look at 10.2.1c, angle O1 is 60. Angle at the center is equals to twice angle at the circumference. Therefore, OBA will be 90 degrees. Radius perpendicular to the tangent. come to 10.2.1 D. I think this was also typing error. It has to be 10.2.1 D. So angle O1 becomes 60 degrees. It is also equals to E, corresponding angles, because of the parallel lines in our diagram. And then 10.2.2, we are to look for angle C1, which is equals to angle E, exterior angle of a cyclic chord, CA, and then the reason must be accuracy mark. And therefore FB is equals to FE. They were required to prove that FC is equals to FD. Another alternative, they can also say FB is equals to FE, sides opposite equal angles. And then they say equilateral triangle DE will be equals to CB. And then this would be the total mark of question 10. And then coming to question 11, colleagues. Question 11, they need to also complete the theorem statement. It is parallel to the other side of a triangular statement, accuracy mark, to complete the theorem statement. Now here, they want to prove that DF is parallel to BC. And then start by saying OGC is equals to 90 degrees. There's a mark, as you can see on the marking guideline, one mark for OGC. And then what is the reason thereof? Tangent perpendicular to the radius. And then OEF is also equals to what? 90 degrees. The reason here is given. And therefore, if we have equal angles that are corresponding, we can conclude that DF is parallel to BC. Okay, colleagues, we move to 11.2.2. Number A, we are given the ratio there. It's a mark for proportionality and a simplified ratio. Another alternative, learners can say OD over OB is equals to OF over OC, DF over BC, which is the same as 3 over 5. And then question 11.2.2. If it's answer only here, colleagues, on 11.2.2a, answer only, we give full marks. And then if we come to 11.2.2 number B, we are requested to find the side of EG, the length of EG. And then it gives us 12 over 5 units, or 2,4 units. And then we move to the next page. Another alternative given, learners may approach it with this way, where they say OD over OE, OD over OB is equals to OE over OG. So if you realize here, they make OE the subject of the formula, they get OE to be 3.6. And then to find EG, we just say 6 minus 3.6. It is giving us 2.4, the same answer. 11.2.2c, area of triangle OBG all over area of triangle ODE. I think here is just a substitution, and the learners are getting the same answer, 25 all over 9. And then there are alternatives given, colleagues. Please, let's follow the guideline as we mark. And you can realize that this is CA from 9.2.2b. It means the answer that is learners obtain in 9.2.2b will have the influence here. Hence, the mark allocation will be CA. I'm sure we are aware of, colleagues. And then 11.3.3, learners were to prove that these two triangles are similar. So a mark for statement DOE is equals to BOE, common angle. And then OE is equals to OGB. It has been proved to be 90 degrees. And then ODE is equals to OBG. That will be the third angle. Therefore, under these conditions, we can now conclude that triangle DOE is similar to triangle BOG. Okay, colleagues. And then we come to page 24. That will be the last mark, which is the given alternative as well. If learners approach it with this approach to say in triangle DOE, OE is given as 3.6 all over OG, which is 6. And then the ratio thereof becomes 3 over 5. And then OD over OB will be 6 out of 10, which is also be 3 over 5. And therefore DOE is similar to BOG. Corresponding sides are in proportion. That will be the end of question 11. Mr. Lidibana said question 12 has been cancelled out. We are not going to discuss it as it was taken out of the question paper. Colleagues, thank you very much for your attention, and I hope we mark according to